MicroTugs. Developed at Stanford University, MicroTugs are ultralight climbing robots engineered to pull loads vastly exceeding their own mass. Each unit measures roughly 1 in times 1 in and weighs between 0.4 and 0.6 ounces. Despite their size, they employ 3 distinct actuation architectures. Piezoelectric, PZT, biomorph actuators. These flex when electrically energized, producing rapid microsteps at up to 10 steps per second under load. This configuration can pull approximately 10 times its body weight. Shape memory alloy, SMA, wire system, heated wires contract to create motion. Although slower and less energy efficient, this version can pull over 5.5 lb, roughly 500 times its own weight. Motor and winch system, incorporates geared transmission, friction clutch, and rolling stick motion. This is the most powerful variant, capable of pulling up to 48 pounds, nearly 1,800 times its weight, with optimal efficiency at step lengths of about 1/6 inches. Surface adhesion relies on a silicone microstructure composed of wedge-shaped features approximately 4,000 nanometers tall, inspired by gecko and insect feed. These structures generate shear adhesion through van der Waals forces, sustaining roughly 70 kPa in shear and 15 kPa in normal force. Adhesion decreases if force changes abruptly. In controlled experiments, 6 robots weighing just 0.6 ounces each collectively pulled a 1.8-ton car across glass. Research continues on swarm coordination and applications in hazardous or confined environments. Arma Scooter. Manufactured by Japanese company Shimizu, the Arma Scooter is a foldable electric micromobility device designed for last-mile urban transport. When folded, it approximates the footprint of a sheet of paper and weighs about 10 pounds. Max speed, 15 miles per hour. Range, 7 to 10 miles per charge. Charging, USB-C, 2 hours. Load capacity, 220 pounds. Controls, thumb throttle and brake buttons. Display, integrated speed and battery monitor. It unfolds in under 30 seconds and is intended for short urban commutes rather than rough terrain or long distances. Micro-sized camera. Engineered at Princeton University, this lensless camera measures approximately 0.5 mm, 0.02 in, across, comparable to a grain of salt. Instead of a conventional curved lens, it uses a flat metasurface fabricated from silicon nitride containing 1.6 million nanoposts, each roughly virus scale. These nanostructures manipulate light phase and dispersion, enabling full-color, wide-angle image capture. Rather than forming a direct optical image, it captures encoded optical data reconstructed computationally using machine learning algorithms. A later iteration stacks roughly 50 metasurfaces, allowing partial optical data processing such as object recognition up to 200 times faster and with significantly reduced power consumption compared to traditional digital processing. Shine 2.0 Portable Wind Turbine. The Shine 2.0, developed by Aurea Technologies, is a compact off-grid wind turbine weighing about 3 pounds. Folded size, 13.8 in × 4 in. Blade span, deployed 23.6 in. Output, up to 50 W at 28 mph wind. Start-up wind speed, 8 mph. Battery, 12,000 mAh, 44 Wh, lithium-ion. Outputs, USB-C, up to 75 W, USB-A, micro USB, 12V. An integrated MPPT controller optimizes energy capture, and a mobile app provides real-time performance data. It can operate continuously when wind is present, including at night. Flyability Elios. The Flyability Elios is an industrial inspection drone for confined environments such as mines, tunnels, and tanks. Dimensions, 19 in wide x 15 in high. Weight, 4.4 lb. Flight time, 12.5 minute, 9 minutes with LiDAR active. Camera, 4K resolution. Mapping, SLAM with up to 1.3 million points/SEC. Control range, 1,640 feet, AES-128 encrypted link. Encased in a protective cage, it tolerates minor collisions. Sensors include IMU, stereo vision, TOF rangefinders, and onboard LiDAR for 3D mapping. SeeStar S30. Produced by ZWO, the SeeStar S30 is a compact digital telescope weighing 3.6 pounds. Lens, 30 mm aperture, 150 mm focal length, f/5. Dual cameras, narrow, 2.46 degrees, and wide, 23.2 degrees, fields. Storage, 64 GB, 50 GB usable. Battery, 6 hours. Filters, UV/IR cut, OIII, H-alpha, solar. App controlled via Wi-Fi/Bluetooth, it automatically tracks celestial objects and stacks images to reduce noise, even under urban light pollution. Pocuter One. The Pocuter One is a coin-sized programmable microcomputer running on a 32-bit ARM Cortex MCU at 48 MHz. Display, 0.95 in OLED, 96x64px, 16-bit color. Memory, 256 KB flash, 32 KB RAM. Storage, microSD up to 512 GB. Sensors, microphone, accelerometer, light sensor. Connectivity, USB-C. It runs Pocuter OS and supports development via Arduino or ESP-IDF. Razer DXT Drift Trike. Built by Razer USA, the DXT Drift Trike is a gravity-powered three-wheel vehicle. Frame, welded steel. Front wheel, 20 in pneumatic. Rear wheels, 10 in HDPE. Weight, 19.5 pounds. Rider limit, 198 pounds. Designed for controlled downhill drifting on smooth surfaces. Sony AS-DT1. The Sony AS-DT1 is a compact 3D depth sensor using direct time of flight with a SPAD detector. Range, up to 33 feet, indoor up to 130 feet at 50% reflectivity. Accuracy, 2 in. Frame rate, up to 30 FPS. Field of view, 30 degrees. Ingress rating, IP65. Suitable for robotics, drones, and warehouse automation. Foams, fluidic origami artificial muscles. Developed at Harvard University, foams are vacuum-powered soft robotic actuators. They consist of foldable origami skeleton, flexible outer membrane, internal fluid medium. When vacuum pressure is applied, the structure contracts to less than 10% of its length. Movement characteristics depend on fold geometry and medium, air for speed, liquid for force. Applications include surgical tools, assistive exosuites, and space robotics. MIT Tiny Hopping Robots. Engineered at Massachusetts Institute of Technology, these thumb-sized robots weigh under 0.04 ounces and jump up to 8 in height using spring-loaded actuation. Artificial muscle-powered wings stabilize flight. They can traverse grass, ice, or uneven surfaces and survive thousands of jumps without structural degradation. Butterfly IQ3. Manufactured by Butterfly Network, the IQ3 is a handheld ultrasound probe. Ultrasound elements, 9,000. Frequency range, 1 to 12 MHz. Modes, 2D, M mode, Doppler, biplane. Frame rate, 28 FPS. Battery, 2 hours. It connects to smartphones and supports AI-assisted measurements. Yonbo. Developed by Intuition Robotics, Yonbo is a 10-in social robot with emotional AI. Camera, 5 MP. Microphones, 4. Processor, quad-core 1.9 GHz. Memory, 4 GB RAM. Battery, 3.5 hours. It detects tone, facial expression, and behavioral cues to adapt interactions. LG CineBeam S. The LG Electronics CineBeam S is an ultra-short-throw 4K projector. Resolution, 3840 x 2160. Brightness, 500 ANSI lumens. Contrast, 450,000:1. Color, 154% DCI-P3. Light source, RGB laser. Supports HDR10, HLG, HDMI, USB-C, and WebOS streaming. Perovskite solar cells. Commercialized by Oxford PV, Perovskite silicon tandem panels exceed traditional silicon efficiency limits. Certified efficiency, 24.5%. Structure, Perovskite top layer, 1.5 EV band gap, plus monocrystalline silicon base. Configuration, 72 cell modules. They deliver 20% higher output than comparable silicon panels. Nissan Engine lineup. The Nissan Motor Corporation 2025 Nissan Z features a 3.0L twin-turbo V6 producing 400 HP and 350 lb-ft torque. Other engines include 2.5L inline-4, 188 HP, in Altima. 3.8L V6 in petrol, 260, 280 HP. VQ Series V6, up to 350 HP. GTR Twin Turbo V6, 565 HP. Recent innovations include variable compression turbocharged engines delivering up to 268 HP. If you would like, I can continue with the remaining inventions: Splay Max, Twopan Nano SSD, E-Wings, Carv, Rocket Airboard, CubeStar, Causal Chambers, Underwater Jetpack, etc., in the same structured technical format. Continues. Continuing with the remaining inventions in structured technical detail. Splay Max. Developed by Aravia, the Splay Max is a foldable display and projector hybrid engineered for portable productivity. Display mode. Screen size, 35 in. Resolution, 1920 x 1080, Full HD. Aspect ratio, 16:9. Brightness, up to 760 nits. The screen material is a nano-coated polymer designed to resist creasing and surface oils. A tensioned mechanical armature maintains flatness during deployment. Projector mode. Projection size, up to 80 in. Light engine, Texas Instruments DLP. Brightness, 285 lumens. Optics, ultra short throw. Auto keystone correction included. Battery, 20,000 mAh, 4 hours use. Ports, HDMI, USB-C, USB-A. Weight, 3.5 lb. It folds to the size of a hardcover book and is intended for field presentations, remote work, and mobile entertainment. Twopan Nano SSD. Manufactured by Twopan, this ultra-compact USB-C solid-state drive integrates encrypted biometric security. Dimensions, 20 x 13 x 5 mm. Weight, 5 g. Capacity, 512 GB. Transfer speed, up to 450 MB/s. Security, fingerprint sensor, stores up to 20 prints. Constructed with an aluminum and impact-resistant composite shell, it operates driver-free across Windows, Mac OS, Android, iOS, USB-C, PS5, and Steam Deck platforms. E-Wings electric wingsuit system. Developed by French wingsuit pilot Vincent Delecluse in collaboration with BMW engineers, the E-Wings system integrates 4 electric turbines into a standard wingsuit platform. Thrust per turbine, 20 kW. Total system weight, 26.5 lb. Battery, 50 V lithium-ion. Deployment altitude, 10,000 feet. Turbines are mounted to a chest plate synchronized with body motion. Control is sleeve-mounted and operated via finger interface. Over 30 live test jumps validated thrust modulation, balance stability, and emergency shut-off systems. Causal Chambers. Created by researchers at University of Oxford, causal chambers are physical experimental systems designed to test AI causal reasoning. 2 configurations exist. Airflow chamber uses fans and valves to model pressure and wind interactions. Light reflection chamber uses controlled light sources and photometric sensors to measure scattering and reflection. Each system records up to 10 measurements per second. The entire platform is open source, including hardware schematics and a Python control package, allowing remote experimentation with real-world cause-effect datasets rather than simulations. Robotic arm platform. This desktop robotic manipulator is built around an Arduino-compatible 8NG2560 controller. Reach, 13.5 in. Payload, 1.5 lb. Precision, plus or minus 0.004 in. Speed, 100°/S joint rotation. Noise level, 60 dB. Power supply, 12V/5A. It supports Python, C++, ROS1, and ROS2 programming. Interchangeable end effectors include laser engraver, suction cup, gripper, pen module, and camera mount. Designed for lab, classroom, and prototyping environments. Carv Ski Tracker. Produced by Carv, Carv consists of dual motion sensors clipped to ski boots. Weight per unit, 1.6 Oz. Battery life, up to 5 days. Connectivity, Bluetooth Low Energy. Metrics tracked, edge pressure, balance, timing, weight distribution. The system generates a ski IQ score across 10 performance metrics and provides real-time audio coaching. It adapts feedback based on terrain type, groomed, powder, moguls. Sport underwater jetpack. Developed by CubeStar, this wearable underwater propulsion system uses dual wrist-mounted thrusters powered by a backpack battery. Top speed, 6 mph. Max depth, 30 feet. Weight, 11 lb. Runtime, 60 minute, moderate, 15 minutes, full power. Recharge time, 3 to 4 hours. Independent arm controls enable directional steering without external handles. Intended for snorkeling and freediving, not scuba applications. F1 Rocket Air. Manufactured by F1, the Rocket Air is an inflatable hydrofoil board using drop stitch construction. Sizes, 4 feet 10 inches to 7 feet 11 inches. Inflation pressure, up to 21 psi. Weight range, 8.5, 19 lb. Volume range, 75 to 190 L. Features include a 4-point foil mount, full-length deck pad, and optional fin tracks. Larger models support windsurf mast inserts. CubeStar Educational Satellite Kit. CubeStar follows the 1U CubeSat standard, 4 in per side. Designed for STEM education. Sensors, temperature, pressure, 3-axis acceleration, magnetometer. Telemetry, LoRa 433 MHz, Gen 2 up to 12.5 miles. GPS, included in second-generation version. Preloaded firmware allows immediate experimentation, while advanced users can customize via coding. Suitable for classroom, balloon, drone, or ground vehicle deployments. Perovskite silicon tandem solar panels. Commercialized by Oxford PV, these panels combine a perovskite top layer with monocrystalline silicon. Efficiency certification, 24.5%. Band gap, perovskite layer 1.5 eV. Configuration, 72 cell module. The perovskite layer captures high energy photons while silicon absorbs lower energy wavelengths, increasing total energy yield approximately 20% over standard silicon modules. 2025 Nissan Engine Technologies. from Nissan Motor Corporation. Nissan Z 3.0L twin-turbo V6, 400 HP, 350 lb-ft torque. Altima 2.5L inline-4, 188 HP. Patrol 3.8L V6, 260, 280 HP. GTR twin-turbo V6, 565 HP. Advanced developments include variable compression turbocharged engines producing up to 268 HP, dynamically adjusting compression ratios for efficiency and performance balance. If you would like, I can now compile all 25 inventions into a clean, copyright-safe, narration-ready master script formatted for YouTube or documentary voiceover. Continues. Continuing with additional advanced inventions and emerging technologies. Jetson One Personal eVTOL. Developed by Jetson, the Jetson One is a single-seat electric vertical takeoff and landing (eVTOL) aircraft engineered for recreational flight. Airframe. Aluminum space frame with carbon fiber composite panels. 8 electric motors, quad-redundant configuration. Performance. Top speed, 63 mph, 102 km per hour. Flight time, 20 minutes. Battery, high discharge lithium-ion pack. Weight, empty 86 kg. Max pilot weight, 210 lb. Safety systems. Hands-free hover stabilization. Triple redundant flight computers. Ballistic parachute system. Designed for intuitive joystick control, it aims to make personal aviation accessible without traditional pilot complexity. Vollaback solar charged jacket. Created by Vollaback, this garment integrates photoluminescent materials capable of absorbing UV radiation and emitting visible light after dark. Material composition. UV-reactive phosphorescent membrane. Lightweight synthetic shell. Functionality. Charges in sunlight. Glows in low-light environments. No batteries required. Primarily an experimental exploration into energy-reactive clothing, it demonstrates passive light storage through material science rather than electronics. Sarcos Guardian XO exoskeleton. Developed by Sarcos Robotics, the Guardian XO is a full-body, battery-powered industrial exoskeleton. Capabilities. Lifting capacity, up to 200 pounds repeatedly. Force amplification ratio, 20:1. Operating time, 8 hours, hot swappable batteries. Degrees of freedom, 24+. Applications. Aerospace manufacturing. Logistics and warehousing. Defense material handling. It reduces musculoskeletal strain while maintaining precise operator control through active force feedback systems. Lilium Jet. Produced by Lilium, the Lilium Jet is an all-electric regional air mobility aircraft. Configuration. 30+ duct electric fans integrated into wing flaps. Vertical takeoff transitioning to fixed wing cruise. Specifications, target. Range, 155 miles. Cruise speed, 175 mph. Seating, 6 passengers plus 1 pilot. The distributed electric propulsion system reduces noise and allows for compact vertiport operations. Neuralink brain-computer interface. Developed by Neuralink, this implantable brain-machine interface enables bidirectional communication between neurons and digital systems. Technical features. Ultra-thin polymer threads, 4-6 μm thick. Robotic surgical insertion. Wireless data transmission. Use cases, research stage. Motor function restoration. Assistive communication for paralysis. Neural signal decoding. The system records electrical impulses from cortical neurons and transmits them to external computing devices for interpretation. Hyundai Tiger X1 walking vehicle. Engineered by Hyundai Motor Group, Tiger, transforming intelligent ground excursion robot, is an unmanned mobility platform. Design. 4-wheel drive. Each wheel attaches to an articulating leg. Functionality. Operates in rolling mode on flat terrain. Converts to walking mode for uneven surfaces. Designed for remote terrain exploration, disaster response logistics, and potentially extraterrestrial missions. Hyperloop concept pods. Originally proposed by Elon Musk, Hyperloop transportation concepts are being developed by companies such as Virgin Hyperloop. Core principles. Near vacuum tube environment. Magnetic levitation. Linear electric propulsion. Projected performance. Target speeds, 600 to 760 miles per hour. Reduced aerodynamic drag. Lower theoretical energy consumption per passenger mile. Although still experimental, prototypes have demonstrated scaled test runs. Pivotal Helix personal aircraft. Manufactured by Pivotal, the Helix is a lightweight personal electric aircraft. Features. Single seat. Tilted propeller array. Fixed wing cruise configuration. Performance. Flight time, 20 minutes. Designed for ultralight classification in the US. It is controlled via simplified joystick interface and automated stabilization software. Agility Robotics Digit. Developed by Agility Robotics, Digit is a bipedal robot optimized for logistics environments. Capabilities. Payload, 35 lb. Height, 5'9". Autonomous navigation with LiDAR. Designed for warehouse automation, Digit can walk through human-designed spaces, handle packages, and integrate into existing supply chains. Carbon-negative concrete by CarbonCure. Developed by CarbonCure Technologies, this system injects captured CO2 into wet concrete during mixing. Process. CO2 mineralizes into calcium carbonate. Permanently embedded in the matrix. Benefits. Reduces carbon footprint. Increases compressive strength. Lowers cement demand. This innovation addresses emissions from one of the most carbon-intensive industries globally. If you would like, I can now compile all inventions from start to finish into a single, polished, copyright-safe master narration script suitable for documentary, YouTube automation, or professional voice-over production. Continues. Continuing with additional breakthrough technologies and next-generation engineering systems. Boston Dynamics Atlas. Developed by Boston Dynamics, Atlas is a fully electric humanoid robot designed for high mobility manipulation tasks. Physical specs: height, 5 feet. Weight, 196 lb. Degrees of freedom, 28 plus. Capabilities: dynamic balance recovery, parkour level agility, autonomous object manipulation. Atlas integrates advanced model predictive control and reinforcement learning to coordinate full body motion in real time. Skydio X10 autonomous drone. Manufactured by Skydio, the X10 is an AI-powered drone built for industrial inspection and public safety. Navigation system: 360 degrees vision via multi-camera array. NVIDIA onboard AI processor. Performance: flight time, 40 minutes. Max speed, 45 mph. IP55 weather resistance. Designed for GPS-denied environments, it uses visual inertial odometry and obstacle avoidance to operate autonomously. Toyota Mirai hydrogen fuel cell vehicle. Produced by Toyota Motor Corporation, the Mirai uses a proton exchange membrane (PEM) fuel cell stack. Powertrain: hydrogen tank pressure, 700 bar. Electric motor output, 182 HP. Range, 400 miles. Hydrogen reacts with oxygen in the fuel cell stack to generate electricity, with water vapor as the only direct emission. Zipline autonomous delivery drones. Operated by Zipline, these fixed-wing drones deliver medical supplies in remote regions. Specifications: range, 50, 100 miles, round trip. Cruise speed, 70 mph. Payload, 4 lb. Using catapult launches and parachute drop systems, Zipline supports healthcare logistics across Africa and other regions. Aptera solar electric vehicle. Developed by Aptera Motors, this three-wheeled vehicle integrates high-efficiency solar panels into its body shell. Efficiency: drag coefficient, 0.13. Solar range gain, up to 40 miles/day, ideal sun. Total range, up to 1000 miles, battery variant. Lightweight composite construction reduces energy consumption to roughly 100 Wh/mile. Formlabs Form 4 3D printer. Produced by Formlabs, the Form 4 uses mask stereolithography, MSLA. Build volume: 200 x 125 x 210 mm. Features: industrial grade resin compatibility, high-speed light engine, automated resin handling, optimized for rapid prototyping and small batch manufacturing with micron-level precision. Archer Midnight eVTOL. Developed by Archer Aviation, Midnight is a piloted electric air taxi. Configuration: 12 electric propellers. Tilt rotor configuration. Targets: range, 100 miles. Cruise speed, 150 mph. Rapid recharge between flights, 10 minutes target turnaround. Designed for urban air mobility networks connecting city centers to airports. NVIDIA H100 AI GPU. Manufactured by NVIDIA, the H100 Hopper architecture is optimized for large-scale AI workloads. Key specs: Tensor core acceleration, HBM3 high bandwidth memory, Transformer engine for large language models. Used in data centers for training and inference of generative AI systems, scientific simulations, and high-performance computing. Ocean Cleanup System 03. Engineered by the Ocean Cleanup, System 03 is designed to remove plastic from ocean gyres. Design: U-shaped floating barrier. Passive collection via ocean currents. Scale: hundreds of meters in length. Modular deployment. Collected plastic is processed and recycled into consumer products. Figure 01 humanoid robot. Developed by Figure AI, Figure 01 is a general-purpose humanoid robot. Capabilities: autonomous task execution, vision language AI integration, dexterous manipulation. Designed to operate in warehouses, manufacturing, and eventually service industries. If you would like, I can now combine everything into a single high-impact documentary script. Format it as a YouTube automation narration with hooks and retention triggers. Organize it into themed categories: aviation, robotics, energy, wearables, AI, mobility. Convert it into a clean blog-ready article. Tell me the exact format you want next. Continues. Continuing with additional frontier technologies across aerospace, computing, energy, and mobility. SpaceX Starship. Developed by SpaceX, Starship is a fully reusable super heavy lift launch system designed for interplanetary transport. Architecture: two-stage system, Super Heavy booster plus Starship upper stage. Stainless steel structure. Methane/LOX propulsion, Raptor engines. Performance targets. Payload to LEO, 100, 150 metric tons, reusable configuration. Height, 120 meters, combined stack. Rapid reusability objective. Designed for satellite deployment, lunar missions, and eventual Mars colonization. Boom Supersonic Overture. Built by Boom Supersonic, Overture is a next-generation commercial supersonic jet. Specifications: target. Cruise speed, Mach 1.7. Range, 4,250 nautical miles. Capacity, 65 to 80 passengers. It uses sustainable aviation fuel, SAF, compatibility and is engineered for lower sonic boom impact compared to Concorde-era aircraft. Quantum System 1. Developed by IBM, Quantum System 1 is an integrated superconducting quantum computing platform. Core technology: transmon qubits. Cryogenic dilution refrigeration, 15 millikelvin. Quantum volume optimization. Designed for enterprise research applications in cryptography, material science, and complex optimization problems. Joby Aviation S4 eVTOL. Produced by Joby Aviation, the S4 is an electric air taxi platform. Configuration: 6 tilting propellers. 5-seat capacity, including pilot. Performance: Top speed, 200 mph. Range, 100 miles. Low acoustic footprint relative to helicopters. Designed for short-range urban and regional mobility corridors. Rolls-Royce Ultrafan engine. Engineered by Rolls-Royce Holdings, Ultrafan is a next-generation turbofan demonstrator. Technical highlights. Geared architecture. Composite fan blades. 140-inch fan diameter. Efficiency goal. 10% fuel efficiency improvement over Trent XWB. Intended for wide-body aircraft and compatible with sustainable aviation fuels. Tesla Optimus humanoid robot. Developed by Tesla, Optimus is a bipedal humanoid robot aimed at general labor automation. Specifications, prototype stage. Height, 5'8". Payload, 45 lb. Actuation, electric servo motors. Designed for repetitive or hazardous tasks within manufacturing and logistics facilities. Commonwealth Fusion Systems Spark. Developed by Commonwealth Fusion Systems in collaboration with MIT, Spark is a compact tokamak fusion reactor. Core concepts. High-temperature superconducting magnets. Deuterium-tritium fusion. Net energy gain objective, Q1. If successful, it aims to demonstrate commercial-scale fusion viability within this decade. Relativity Space Terran R. Built by Relativity Space, Terran R is a reusable, 3D printed orbital launch vehicle. Features. Methane-fueled ENR engines. Automated additive manufacturing. Reusable first stage. Designed for medium to heavy satellite payload deployment. Rimac Nevera electric hypercar. Produced by Rimac Automobili, the Nevera is an all-electric hypercar. Performance. Power output, 1,914 HP. 0 to 60 miles per hour, 1.85 seconds. Top speed, 258 mph. Battery, 120 kWh. Utilizes quad-motor torque vectoring for extreme acceleration and handling precision. Vertical Aerospace VX4. Developed by Vertical Aerospace, the VX4 is a piloted electric aircraft. Configuration. 4 passenger capacity plus pilot. 8 propellers. Target performance. Range, 100 miles. Cruise speed, 150 mph. Significantly lower noise profile than helicopters. Designed for commercial urban air mobility services. This completes a large-scale survey of cutting-edge systems across aerospace, robotics, clean energy, artificial intelligence, advanced mobility, sustainable materials, human augmentation. If you want, I can now convert everything into one seamless long-form documentary script. Structure it as a top 50 future